Advanced Algebra 6.4. We're going to look at radian measurements of angles. Okay. There's really two different ways that those radian angles can be written. And one way is written just as a decimal. Okay. So that's what we're going to look at in this one. The other way is in terms of pi. I'm going to do that in a separate lesson. So I have a circle here, and it has different divisions in this. So if I look at where my axis is, so I have my x-axis right along here, and my y-axis here. So if I'm drawing the angles in standard position, I start here, and then I come to my first line that's drawn in here. This first line that comes out. If I take this arc on the outside and I compare it with a radius, those two are equal measures. This angle in here is called 1 radian. The arc length and the radius are equal. So our arc length equals radius. So I could have a circle that's much bigger, okay, but the radius would be bigger, and then when I would curve it around the arc, I would still get the same angle here. So I'm going to label these out here. So this is going to be 1 radian. I go another radius length, so I'm at 2 radians here. Another radius length, 3 radians. And that's just shy of being halfway around. We've got 4 radians over here, 5 radians here, 6 radians, and then I have just a little bit before I'm back to the beginning. So if I start filling in some of these things here, a radian is an angle measurement. That is the ratio of the arc length to the radius. One radian creates an arc the length of 1 radius. That's what we're looking at over here with this green angle here. Our arc length equals the radius. So if I see a full rotation, I'm just past 6 radians, and actually as a decimal, this is going to be 6.28 radians, okay, because that is about equivalent to 2 pi. In half a rotation, then, we'll have half of this. So 3.14, which is about what pi is. So when I want to draw different radian measures, it's much different than degrees. In degrees, we have 360 degrees and a full rotation. Here we have 6.28 radians. So if your calculator is in the wrong mode, your answers are going to be much different. 1 radian is about 57 degrees. Okay, so that's not a precise measurement, but it's an approximate. So if I want to draw some of these other angles, it would be really helpful to know where my axes lie, so where my x and y axis is. So if I look over here, again, I said 3.14, and all the way around would be 6.28. So if I look at my y-axis at the top, I'm looking at half of 3.14. So I'm at 1.57 radians. I can see that was in between 1 and 2 radians, a little bit past 1.5. So that 1.57 makes sense. The bottom, I see it's in between 4 and 5 radians, a little bit closer to 5 radians. So if I look at what's halfway in between 3.14 and 6.28, I'm at 4.71 radians. Those decimal values are going to help me. So now when I'm graphing these, I'm going to draw my x and y axis. So a couple ways I can think of this is that 2.5 radians means I'm going to go 2.5 radius lengths around. So I'm going to go a distance from my x-axis. So this is my radius. So I'm going to go 1 radius, 2 radius, and about a half. Ending about there. I can draw my terminal side out from there. If I also go back to my circle, I'm looking at halfway between 2 and 3. Can I see it's really close to being in the middle of that second quadrant. A little bit further, just like my picture shows here, I'm a little bit further than halfway through. So if I look at the next one, 5.25 radians. So again, I can count different radius lengths. So whatever I go out, so I'm starting out here, this length is how far I want to go. So I've got 1, 2, 3 is just going to be shy of one full rotation. 4, 5, and I need to do another quarter. Or if I'm looking up here, I'm at 5 1/4. Okay, with the same kind of placement here. My last one is a negative value. So I'm going to just go a different direction around this rotation. So again, I'm going to start out here, a radius length, but now I'm going to go clockwise. So 1, 2, 3 is just shy of one rotation. And then I need to go another half radius. So I'm going to be up in this upper one. That's a harder one to use up here, but if I looked at a positive 3.5, I'd be over here. And so that really reflects up into the second quadrant. And so I can see that it does reflect up here into that second quadrant of that same distance. Now, sometimes you might have radian angles that are more than 6.28. And so then you're just looking at how much further past 6.28 you're going. So you can go either direction, positive or negative, and looking at how many radius lengths you're traveling.